This is a demonstration of the kind of problems you may run into when trying to simulate a VHDL entry in your Xilinx system, a VHDL counter. So I'll start by doing a new project, and I'll create a counter project. So this will be my counter2 project, and the idea is that I'll put in a counter right from these what's called language templates, and see how it will simulate. So this is a VHDL module, and this is my sum counter. I'll add this to the project. I will not put in port modules. I will take them from the language template. So I'll go to the language template, VHDL part. I'll find some synthesis constructions, I'll find some coding examples, and here I'll find the counters. Here's a bit of example code which I will steal right away. Control C, and I'll put it back in my counter. Control V, there it is. So this is a simple counter with clock input, clear input, and Q output. See if this counter will actually see if this counter will check syntax. There it is. Yes, I'm interested. And it completed the syntax check. So I'll do a simulation of this verifying counter. I will create a test bench, VHDL test bench. So this is a counter test. Next. This is the counters 1, and finish. Looking at this is quite clever. It finds out that I need a clock input, and it actually starts the clock process going 0, going 1, going 0 for a clock period previous, which is defined to 10 nanoseconds, and everything is quite good. So I will try to run this counter test. You can see the counter test goes to the counter. I will see if I can check the syntax of this, and it will presumably work. It works okay. So I'll simulate the behavioral model. And now I'm into the first problem. Looking at the output, I can see that I have X's for my output Q3 to 0. Zooming into the start of this, I can see they are unknown, and they go into some other kind of unknown here. This is due to the fact that the counter is not reset at the start. So first thing I can do about that is I can use the clear input. So knowing that my counter has a clear input, and that if the clear is 1, the variable or the signal inside will be set to 0, 0. So if I go in the counter test and set up the clear to being a 1, CLR being a 1 for 100 nanoseconds, and then I can set the same signal to being a 0, and that should do the trick. So I'll save this, and if I go to the simulator, I can use this facility of relaunching, and it will go back and relaunch all the inputs, and I've got something that kind of runs. it will be undefined in the first half of the clock period. When the first clock period goes positive and my clear has a value of 1, the output goes 0. Then when the clear goes low over here and I have a next positive transition, my counter starts counting. Closing down this, I want to exit yes. If I have another counter that may not really have the clear input, I'm in another problem, and maybe I have counters without any clear inputs. So I will generate myself a new counter. This will be my some counter 2. Yes. This is a VHDL code. This is a VHDL module here. Next. And I'll still not put in the input outputs, so here is my next counter. Some counter 2. Still an empty project. I delete all the effects inside. I think I'll take the example code once again. Control C and go to the sum counter 2 and paste it here. But this time I will leave out the clear and I will leave out if the clear is 1, else part, and I think I've got 1 too many lifts. Yeah. So this is just a very basic counter that only counts forwards and nothing else happens. So now I want to save this counter. I've got something like the entity is called counter 1. So maybe I'll change this to counter 2 to keep track of what I'm doing. So this is the architecture of counter 2. So I'll save this counter 2, here it is, and I'll try to do a test bench of this. First I think I'll do a counter 2. I'll see if I can check the syntax of this. Of course I can do that. Checking the syntax, I will do a simulation of counter 2. So I'll do a test bench. VHDL test bench, and this is test counter 2. And it goes to counter 2. Next. Finish. So everything looks right. Clock input Q, clock and Q. So there's no clear here, which is okay, and everything looks just as it's supposed to do. So looking at the facilities for this counter test, which tests counter 2, I can check the syntax. It will come out okay, I guess, and I can try simulating the behavioral model, which will not come out okay. So I've still got some, or I'm back again to unknown inputs. And I'm moving from unknown to another kind of unknown or errors when the first pulse enters. What can be done about this is the initialization of the VHDL code for the actual counter. In this you have an option. You can set the, and this is this one, you can actually set the starting value of this. So by going into the line where you have the signal, here you have an option. You can set the starting value of this The syntax is a bit strange. This is the assignment uses colon equal sign like this, and not the normal way of assigning in VHDL. So this is the way I can get around the initialization of the system. So I will save this, save all. And another nice trick, I could check the syntax of this. Oh, this is not. Another nice trick is if I go to this simulator, I can relaunch the simulator, and it will run whatever needs to be run, and I can see, well, I'm back again, and thanks to setting the starting value to 0, 0, 0, I don't need a clear signal to do this. So this is my findings in these matters. Over and out.